Okay, so the question said that you had the lottery board, each trial, you had a ball with the digits 0 through 9, and then they tested 25 trials. Okay, so this was the easiest way for me to explain this to my class. When you're dealing with experimental, you're talking about the trials. So we're talking about the 25 trials. You get those numbers from the data. They gave you a little table and it said outcome and number of trials, and then it had 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, so each of these are the numbers 0 through 9 in your machine, and then the number of trials. It said the 0 was pulled twice, the 1 was pulled 3 times, the 2, 0. I'm just getting this from the problem that you sent me. The 5 was pulled 3 times, the 6 4 times, the 7 2 times, the 8 3 times, and the 9 2 times. So if you took all of these and you added them together, you're going to get 25, because they said there were 25 trials. Okay, so your experimental probability is going to come from this table right here. So they want us to find the experimental probability that I would get a 2 or a 3. So you go to your table and you look at, okay, my outcome being 2 or my outcome being 3. Well, 2 showed up 0 times and 3 showed up 3 times. So the probability of a 2 or a 3 would be 3 times out of 25, because 2 was 0, 2 was 0, and 3 was 3. So 0 plus 3 is 3, and that tells me 3 out of 25. And so you're supposed to divide that, because they want it in decimal form rounded to the thousandths place. So I take 3 divided by 25, and I get 0.12, but since they want it to the thousandths place, I'll put that 0 on the end. So that is my experimental probability. Okay, so then next, theoretical. So theoretical is what will happen in theory. What do I mean by that? So when I come up with the theoretical, I'm looking at the object that the problem is talking about. In this case, it's talking about a lottery machine. Sometimes it talks about a dice, sometimes it talks about cards, and so on. Sometimes it talks about a spinner. Okay, so your theoretical comes from the object. So when I look at the object, I'm thinking, oh, okay, so they're talking about one of those lottery machines. So like they have that lottery machine, and they have some kind of ball, and then the little numbers shoot out of that little slot. Okay, so inside of this lottery machine, there's 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are 10 total numbers. Okay, 10 numbers inside of that machine, and the numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now the question is, what is the theoretical probability that I'm going to get a 2 or a 3? Okay, so theoretical, I want a 2 or a 3. So if I look inside of this machine right here, there's only 1 2 and 1 3. And there are 10 total numbers. So I have 2 chances, because there's 1 2 and 1 3. 1 and 1 makes 2 out of 10. And if I simplify that, that's 1/5, but I still have to divide it because they want to the thousandths place. So that would be 0.200. So my theoretical probability is higher. If you look at it, it's 200 thousandths, and my experimental probability is 120 thousandths. So theoretically, I have a better chance from this experiment that they provided. And that the case is here. If you think about the easiest way for you to understand the way that these work is if you think about a company, a pharmaceutical company. If they pick a drug and they say, okay, we think you should try this drug because we tested it. And so we tested this drug on 10 people and we think the drug works. Well, you're probably thinking to yourself, well, you only tested it on 10 people. I don't know if that drug's going to work or not. I want you to test it on more people. So if we get a high, the higher our experimental trials, the closer we get to the theoretical probability. So the more times we try something, if we have 1,000 trials, we should get closer to our theoretical probability. Typically, they're never going to be the same. So your question, it said, assuming that the machine is fair, choose the statement that's true. The first one says, as the number of trials increases, we expect the experimental and theoretical probabilities to become closer, though they may not be equal. That was your choice A. And so that's true, because the higher the number of trials we get, the closer we should get to theoretical. So the answer for your C was the first one. Okay, the second choice was the experimental and theoretical probabilities must always be equal. That's not true. They're not going to be equal. Very seldom will they be equal. And then the third one, as the number of trials increases, we expect the experimental and theoretical probabilities to become farther apart. That's not true. The more times we try something, the closer our experimental should get to our theoretical. Okay? So the big part here is experimental, that's going to be your trials. Okay, so look for a table with your data, and that's where you're going to get your trials from. The theoretical, that's going to be the object. So if it's a lottery machine, or if it's a dice, or if it's cards, or if it's a spinner, you're using the information from those things to get your theoretical. Okay, I hope that helps.